METS Ignited is the industry growth centre for mining equipment, technology and services. Australia's METS sector is a recognised world leader in innovation and technology, delivering the safety, environmental and productivity outcomes that sustain our global resources sector. The success of Australia's METS companies has created more highly skilled jobs and expanded the local economic contribution of Australia's leading technology sector.
Hi everyone, and thank you for tuning in this session called A Deeper Level to Sustainable Mining. And sustainability within the mining industry is becoming more and more important, especially as the mining industry plays a crucial role in delivering the critical raw materials that we need for this transition to a low carbon economy. My name is Tijsseling. I work at Minviro, and Minviro is a consultancy and technology company, and we provide environmental impact data on an asset-by-asset basis using life cycle assessment, which will provide quantitative environmental impact data. And this is becoming more and more important. Reduction of the carbon footprint was identified by Ernst & Young to be a major risk to mining companies. What we do at Minviro is we work with mining and metal projects through all the stages of development, all the way through operation, to understand, quantify, and minimize the carbon footprint using life cycle assessment. And in this case, we don't just address scope 1 or scope 2, we address scope 1, scope 2, and upstream scope 3 emissions. And what we do at the moment, we mainly offer consultancy services where we work with projects throughout the development phase to quantify and understand those environmental impacts and provide with solutions to mitigate those. We're also developing a tool called Material LCA, which will allow mining companies to do these studies themselves. So first, let's talk a bit more about life cycle assessment and what it is. So a life cycle assessment is an inventory of the environmental impacts. In our case, we've tailored it specifically for the battery material projects. And an LCA model looks at a range of environmental impacts, for example, carbon dioxide, also water use or the generation of particulate matter. And in this case, we make sure it always aligns with ISO standards. And the approach that we use allows a company to clearly and transparently communicate about the environmental impacts of their battery material project because we're providing quantitative data. And additionally, environmental hotspots are identified. And with that, this allows to actually make suitable mitigation strategies, which will make sure that the raw materials necessary for the low carbon economy are sourced at minimum environmental impact. And the way that we see it is that it actually comprises of 3 stages. It all starts with quantification, so quantifying and highlighting the main drivers of the environmental impacts of resource projects. Second stage is mitigation, so ensure you make environmentally informed decisions during the delivering of projects. And then the final stage is communication. So with this ISO standard LCA, you can actually have a very clear and transparent way of communicating the impacts of your products and your project to off-takers, investors, OEMs, and of course, the government. So at the moment, we mainly focus on technology metals. And the reason for that being is that the end user of these technology metals, i.e. the OEMs, they want to have minimum impact raw materials. So there's a push from both the investors and the OEMs to gain understanding of the environmental impacts of these projects. So we've actually carried out LCAs for all the battery raw materials. So for lithium, we're actually the first to carry out an LCA to quantify the difference in environmental impacts for lithium hydroxide produced from different natural resources. We've worked on rare earth elements, and we're developing a framework to ensure harmonization of LCA results. We're now doing a lot of work on nickel, especially with the move towards an NMC 811 cathode. We've done work on cobalt and benchmarked a Chinese refinery against a North American refinery, and I'll get back to that in a bit. And we're also, for a manganese project, are developing the first project-specific LCA for high-purity manganese sulphate. And also, of course, we've now mainly talked about materials for the cathode, but graphite is also extremely important for the anode. So we're providing support for graphite projects in development to understand the environmental impact for graphite concentrate and active anode materials. So let's talk a bit more about this LCA study on lithium hydroxide production. So we looked at the carbon footprint of South American brines compared to Australian spodumene. And we can see that Chilean brine has a carbon footprint that's about a third of Australian spodumene that's then converted in China into lithium hydroxide monohydrate. And actually the Australian spodumene, the reason why its footprint is so much higher than Chilean brine is because of the energy that's used in China to for this conversion of spodumene is mainly based on really high carbon sources. And this shows that there's a very strong influence of regional and resource-dependent factors on the footprint of lithium hydroxide. We also did a very similar study for cobalt sulphate refining. So what we got data from a North American refinery and a Chinese refinery, and then looked into did a similar analysis to compare the footprint of a North American refinery with the one in China. And in this case, there were not only regional factors that influence the footprint, but there were also process-dependent factors that defined the difference in cobalt sulfate, in the footprint of cobalt sulfate refining. And this ties into where we think LCA should be used. And that's that early understanding of the environmental impact allows for early mitigation. And what I'll be presenting here is a rare earth oxide case study. And what we saw is that when we did scenario analysis using life cycle assessment, it was possible in the best case scenario to have a difference between best and worst case of almost 400% in kilograms of carbon dioxide equivalent per kilogram of rare earth oxide. And the scenarios that we investigated were the importing of sulfuric acid versus the generation of acid on site. And we looked at different energy solutions. For example, did they connect to the grid for the electricity, or did they use local methods to generate electricity, local renewable methods to generate electricity. And we noticed that for the best, we selected the best case scenario, which of course was renewable powered with battery storage of the electricity. And after that, the project didn't have a carbon neutral status. We still saw that there was an impact of 17 kilograms of carbon dioxide equivalent per kilogram of rare earth oxide. What we see here in the image on the right are the contributors to that carbon footprint, and we can see that the precipitation phase for the majority contributes to this carbon footprint, of which again, if we look down, we see that the majority of that is caused by the use of sodium hydroxide in the precipitation phase. And we think that gaining this understanding early on in the design phase is extremely important to understand where the impact of your project comes from. And so to ensure that LCA can be integrated into project development and sustainability reporting, we're now developing a software as a service platform called Mine LCA, which you can see a wireframe here. And the idea is that the mining and project developers can actually put their data themselves into this online tool, and generate life cycle impact data that you can use to make environmentally informed decisions. So we see that this is a method to enable life cycle thinking for all. And as I mentioned just now, this allows for environmentally informed decision making. And as probably most people know who have developed critical metal projects, the flexibility is maximum in the scoping study, in the PEA. And so the way that we see it is if you integrate life cycle thinking there, you have the possibility to minimize environmental impact at maximum flexibility. And we at Minviro have carried out studies following the full value chain of battery technology materials. And that really shows that if you can mitigate these impacts early on, you can truly get an understanding of where the impacts for the final precursor material come from. We think that in the future, this data should integrate into corporate sustainability and technical reporting of projects. And for example, for projects in development, the data can be integrated with sustainability, York or NI 43.1 reporting, which highlight the technical and economic feasibility, but also in the future, the environmental feasibility of a project. And as I mentioned before, we can make environmentally informed decisions by performing an LCA scenario analysis. You can evaluate a range of project options within the lifecycle context, which allows you to incorporate lifecycle impact data alongside technical and economic metrics. So, some take-home messages. I started this presentation by talking about a deeper level to sustainable mining, and I hope that I've clarified that lifecycle assessment is the most appropriate tool to uncover the variability in environmental impact metrics for minerals and metals from different sources, as I've shown for both cobalt and for lithium. You can quantify sustainability, and an LCA can point you in the right direction to minimize your environmental footprint. And with that, you can make environmentally informed decisions by incorporating lifecycle impact data alongside technical and economical considerations. And with that, I'd like to thank you again for tuning into this session, and make sure to get in touch either through our website or to me personally if you want to trial Mine LCA, or if you want to quantify how sustainable your project or operation is. Thank you again.
METS Ignited is the industry growth centre for mining equipment, technology and services. Australia's METS sector is a recognised world leader in innovation and technology, delivering the safety, environmental and productivity outcomes that sustain our global resources sector. The success of Australia's METS companies has created more highly skilled jobs and expanded the local economic contribution of Australia's leading technology sector.